Okay, from the previous activity, we kind of look at x equals to plus minus x minus p bracket square plus q. So let's just make some conclusions. I think I made some conclusions just now again, but let's just like make it again. It's pretty simple. If we have a graph like that, this means that p comma q is the turning point. And then we also have in this case, x equals to p is the line of symmetry. Okay, so let's draw those graphs, okay, out. Okay, so let's say I have a graph like that. Okay, this would tell me, and a graph like that here. Okay, so something like that. Okay, yeah, maybe like that. This would be fine. Okay, so in this case, the turning point here would be p comma q. The turning point here would be p comma q. Okay, and then we have a line of symmetry that we can draw. Pretty simple. Just draw the line of symmetry out. Okay, this is just simply x equals to p, and this is simply equals to x equals to p also. Okay, so honestly, this is actually pretty simple as compared to other kinds of graphs. And yeah, let's now try to find out what's p and q very easily. Okay, in this table, it's pretty simple. This is simply just p is 8, q is 2, and our turning point will be 8, 2, and this is definitely a minimum point. The equation of line of symmetry, just x equals 8. It's pretty simple. We just read off the graph. Now the thing here, I will talk about the number of x-intercepts later. Okay, and this requires you to understand the functions of the graph. Okay, how do we transpose them? Okay, in this case, this graph does not have like any p, anything that we can x plus p, but in fact, the p here is actually 0. Why is that so? It's because it's I can rewrite this as x minus 0 bracket square minus 8 over 3. So p is 0 and q is negative 8 over 3. So it's such an amazing thing about these general forms. And in this case, this is also like that, and this is also a minimum point, and your line of symmetry is just x equals to 0. Last but the next one we have, this would be negative 14. Your p will be negative 14, your q will be 16. So this is your function. So this is your turning point, and this is a maximum point because there's a negative in front. This is your line of symmetry, x equals to negative 14. Okay. Now next we have this one where your p is 7 over 2, and your q is just an invisible 0, and hence your turning point would be 7 over 2, 0. Okay, and last but not least, this would be a maximum point as well. And x is equals to 7 over 2. Okay, so the question is, how would you find the number of x-intercepts easily? One way, okay, is for you to just equate the equation equals to 0. Okay, so when you equate the equation into 0, it will simply, for example, this will be just x minus 8 bracket square plus 2 equals 0. But you have some issues here because this will be a negative, right? And you cannot actually square the negative. And when you cannot square root the negative, which is over here, this actually tells you that there is no x-intercepts. Okay, I say again, if you equate the equation to 0 and you try to find a solution and you reach this stage where you cannot square root a negative, it simply tells you there is no x-intercepts. Okay, can? So what about second one? The second one, we will have x squared minus 8 over 3 equals 0. And in this case, x squared is equals to square root of 8 over 3. Sorry, not square root. Why do I write square root? It shouldn't be square rooted. Okay, it's equals to 8 over 3. and it can be square rooted, right? This value 8/3 can be square rooted, and it will give you two values of 8/3, right? Plus minus square root 8/3. Sorry, so this will be 2. Okay, next we have this over here. We have negative x plus 14 square plus 16 equals 0. Okay, we have negative x plus 14 square equals to negative 16. Okay, oh, Cher cannot square root. No, you can you will say Cher cannot square root it, so confirm 0 intercepts. Okay, that's not true. There's a negative sign on both sides, so this is equals to 16, and you can square root it. Okay, when you can square root it means you will have two solutions. So you have two x intercepts here as well. Last but not least, we have this over here. You will realize that this has only one intercept. Okay, all graphs with only x minus p square. Okay, they don't have a add something, right? This has only one intercept, which is the turning point itself. So just one intercept. Okay, so just something to take note. In something interesting about all these kind of graphs. So that's about it for this part. We'll catch you at the work example.